Manufacturing with Robotics and Welding Career Academy, located here at the Kirkwood Regional Center at the University of Iowa. My name is Mike Kubis. I'm the instructor here. What we're going to do in this video is show you a couple different projects and multiple machines and processes used to make these two projects, all representing various parts of manufacturing. Okay, the two projects we're going to do, one is called the knot puzzle. It's going to be a CNC job made from aluminum material. The other is going to be a little stool slash end table. This is going to be more of a fabrication welding project. We're going to use 1-inch square tubing, 16 gauge for the top. We're going to cut a few angles so the legs are not just your typical straight up and down corners. We need to figure out the length of the leg. If the overall length here, or height, is 26 1/4, we can subtract 2 inches with the top and bottom. And then we know this leg should be 24 1/4 inches. We have a right triangle here, so we know this is 90 degrees. We know the sum of both of these angles will add up to 90 degrees. We'll call this a big question mark here. The hypotenuse of our triangle, that's another big question mark. This is where we're going to use our SOHCAHTOA method here, or tangent formula would work best for us here, figuring out this first angle. So the tangent of this angle would equal the opposite over the adjacent. And we know those two sides. I would just go right to my calculator, approximately 60 degrees. We know that the sum of a right triangle is 180 degrees, so we automatically know what this one is. It's going to be 30 degrees. So now we know what we can set the saw at, so we get that correct angle. We still need to know the hypotenuse here. The a squared plus b squared equals c squared. 14 squared plus 24.25 squared equals, and then take the root of that, it's 28 inches. So the hypotenuse here, 28 inches. So now we know that we're going to saw cut the lengths of those legs at 28 inches, and we're going to set the saw clamp, that solid jaw, we're going to set it to our 60-degree angle using protractor, and then we can start to cut all the legs. The top and bottom is going to be easy. We'll just set that at a 45 and cut them to 15-inch lengths. Once we get all the pieces cut, then we can deburr them, clean them up, and get them ready to weld. Now that we've figured out the proper angles and the proper lengths of the pieces we need, we will use a horizontal bandsaw and cut our individual lengths. To make the tabletop, we're going to use a machine called a shear and cut out an 18-inch by 18-inch square chunk of steel. We'll take it over to the press brake and we'll bend that edge over, and then we'll make our 90-degree bend so it'll look something like that. It'll be a nice, clean, smooth edge, so we don't have to worry about sharp edges. I've already gone through and calculated what our press brake setup will be to achieve our 15-inch inside between the legs here, so that when we bend the lid, it'll fit right on there snug, and we can clean it up and weld it on. So here we go. Let's cut our 18-inch piece. This here is basically a giant pair of scissors. It's rated for 3/8 material thickness, 4 foot length. I've calculated the dimensions, and we need to go ahead and scribe some lines on there to follow when we use the plasma cutter. So we'll use the plasma cutter and we'll cut near our line on all 4 corners, and then we'll grind and clean them up just a little bit, and then we'll be ready to bend. In regards to the knot puzzle, we're going to have a 2-inch width, and we're going to have to take a 1/2 inch off of that. We will saw cut the 2.5 inch length. We're going to probably saw cut it maybe an 1/8 inch heavy. That way we can take it to the CNC mill and mill the ends off, so we end up with a nice square block, 2.5 inch length, 1.5 inch width by 1/2 inch thickness. Once we get all the blocks squared up, we will need to use an end mill and machine a rectangular pocket centered in the rectangle itself. If we were to machine this with a 3/16 end mill, that would leave a slight radius, so it wouldn't have a nice inside square corner to offset a drilled hole in each corner. And what that's going to do is just take the sharp corner away, leaving plenty of room for the 1.5 inch width of another rectangle to slide in this rectangular pocket. There's going to be multiple operations here. First, we saw cut the length a little heavy, and then we take it over to the mill and we square it up. We'll drill 4 corners and mill out that rectangular pocket, and then what we'll use is a spot drill, and we'll go along the edges here and put a little chamfer to kind of break that sharp edge so we don't have to do so much filing. Then we will stand one up at a time, and we need to mill out I'll call it the C shape. And once we have that all done, then we can do the final deburring and assemble it. So here's our 1/2 inch thick, 2 inch wide aluminum bar stock. Now that we have all these pieces cut, we'll use this giant face mill. It's an insert cutter. We'll put this in the spindle of the mill. I'll sandwich 2 of these in the vise, and bringing it to 1.5 inches, and then we'll put it in the vise lengthwise and come by with a 1/2 inch end mill, and that'll shave down one end. We'll flip it, take the other end down to that 2.5 inch length. Once everything's squared up, we'll use a series of tools, a small .140 drill to drill the corners, and we'll use a smaller end mill, a 3/16 4-flute end mill. That'll go in there and make that rectangular pocket. And then this was the spot drill I was talking about. What this does is it comes by and it'll kind of deburr, put a nice little 45-degree chamfer on there to help reduce some of the filing we'll have to do at the end. Okay, over here I'm at the inspection table. As we're running the rectangle pockets, it's very important that we keep track of our quality and do a periodic inspection. We know we started out with 1.5 inches width, 2.5 length, 1/2 inch thickness. Instead of just a plain 1.5 inches by 1/2 inch, we gave it a little tolerance. So we're going to mill the pocket slightly bigger. So we'll call it 510 thousandths wide and 1.510 for the width of that pocket. It's very important that that is centered. So we would go by and make sure this was 1/2 inch or less. If we come into one that's extremely off center, we're going to want to take that out of the mix. Otherwise, we'll get some puzzles that don't quite go together properly. Too tight a tolerance or too loose a tolerance would be a problem with assembly, and we want to make sure we're making quality products. By the way, did you guys know where they make substandard parts that are not good quality? I believe it's called the Satisfactory. In conclusion, I hope you guys enjoyed this video. I hope this was somewhat informative in regards to manufacturing. If you guys have further interest in manufacturing, I would recommend looking on the explore-manufacturing.org and explore some of the area manufacturers in our specific region. There's a lot of information on that site. Thanks.